Hi, this video is a brief demonstration of the proof of concept implementation of Nvgre on Intel Data Plane Development Kit. Nvgre network virtualization using GRE protocol is a protocol that helps to create more than 16 million layer 2 virtual networks using a layer 2 layer 3 physical network infrastructure. Nvgre does this by tunneling the original IP packet into another IP packet and using one of the GRE protocol fields to set a 24-bit virtual network identifier called Virtual Subnet Identifier, VSID in short. VSID also helps for an Nvgre endpoint to decide if a particular packet should be forwarded to another destination or not. So let me start by introducing the development environment we have used for this proof of concept project. Our objective is to create two virtual subnetworks identified as VSID 100 and VSID 200, as you can see in the red line and green line in the diagram. VSID 100 includes ETH0 port of VM1 and ETH0 of VM4. VSID 200 includes ETH1 of VM1 and ETH1 of VM4. Let's see how this concept is realized in our project environment. We use a Windows 7 laptop with 4 CPUs and 8 GB RAM. This laptop runs Oracle VirtualBox software on that. So VirtualBox acts as a hypervisor which hosts 4 virtual machines on that. VM1 and VM4 are acting as end nodes in the network with 2 interfaces each. We have seen that in the previous slide already. VM1 and VM3 act as Nvgre endpoints. So which means VM1 and VM3 will be responsible for encapsulation and decapsulation of Nvgre header from the packet. VM2 is a simple IP forwarding router in the network. So let's take an example of a packet originating from VM1 to VM4. Let's say the packet originates from ETH0. Now this packet is handed over to Nvgre stack in VM1, and Nvgre encapsulates this packet and sets the appropriate VSID to the packet, and then the packet is sent out to VM2. VM2 looks at the outer IP header and performs packet forwarding to VM3. VM3 receives the packet and hands over the packet to the Nvgre stack again, and this Nvgre stack decapsulates the outer frame and extracts the VSID present in the packet and processes the VSID. And after that, this packet, the original packet after decapsulation, is sent to VM4. A similar process would follow for traffic originating from VM4 to VM1. So the next slide we will see how these VMs are networked using VirtualBox bridges and details of interfaces in each of these virtual machines. So here we have VM1, VM2, VM3 and VM4 connected via VirtualBox bridges. Virtual machine VM1 has 4 interfaces, out of which ETH0 and ETH1 are bound to the native TCP/IP stack. Remaining 2, ETH2 and ETH3, are bound to the DPDK interface. So this means that ETH0 and ETH1 are visible only to the native TCP/IP stack, whereas ETH2 and ETH3 are only visible to the DPDK. Same way, VM2 has two interfaces, ETH0 and ETH1. There is no DPDK running on VM2, so both ETH0 and ETH1 are bound to the native IP stack. VM3 has four interfaces, ETH0, ETH1 bound to the native TCP IP stack, and ETH2 and ETH3 bound to the DPDK. VM4 again does not have DPDK stack, so interfaces ETH0 and ETH1 are bound to the native IP stack. There are 5 bridges in the VirtualBox that create the network of virtual machines that we saw in the previous slide. In this demo, we plan to show two cases. First case is ping traffic from 192.168.0.100, that is ETH0 of VM1 to 192.168.0.101, that is ETH0 of VM4. This is an example of a case of traffic between two nodes in the same VSID. So this traffic is expected to succeed. We will also show another case of traffic from 192.168.0.100, which is again ETH0 of VM1 to 192.168.0.103, which is ETH1 of VM4. So this is a case of traffic between two nodes in different VSIDs, which means that these two nodes are in two different virtual subnetworks. So this case is expected to fail. My colleague Bhargav, who is part of the Nvgre development team, will execute these two cases now.
In this window, we can see three machines. This is machine 1, and this is machine 2, and this one is the machine 3. In machine 1, we have two interfaces, ETH0 and ETH1. This ETH0 is belongs to VSID 100, and this one is belongs to VSID 200. And our DPDK will run here in machine 1 as well as here in machine 3. This machine 2 we will it will act as a router to forward IP packets. We have another machine VM4. We will see later about that one. Now we have two cases. First one is ping between two interfaces which are in same VSID. It expected to work. And another case is ping between two interfaces which are belongs to different VSIDs. So it expected to not work. Now first we need to start DPDK in machine 1. We can see port statistics here. These are statistics of DPDK in machine 1. Now I am going to start DPDK in machine 3 also. Here also port statistics are there. These port statistics are for DPDK in machine 3. Now I am start pinging from this interface. Means ping between two interfaces between VSID. that is case 1. Between same and VSID, that is case 1. Now I'm start pinging. Now I am start pinging. Ping started. You can see packets going. You can see packets here and here also. This belongs to VSID 100. I'll start this one. Now here packet is sent from this machine to DPDK, means this interface, from this interface to this DPDK. In this DPDK we are encapsulating the packet with Nvgre header and IP header and Ethernet frame header, and send it to this machine 2. Now you can see that packet in encapsulated packet in machine 2. These three, Ethernet 2 and IP and ICMP, these three are in original packet. After that we are encapsulating with this GRE and IP and Ethernet 2 in DPDK. In this this GRE header we can see this 64, means hexadecimal 64 means 100. This is VSID, means VSID 100. So as expected it is working. That packet is decapsulated here, and that original packet will send it to VM4. You can see that original packet here. You can see this original packet, means no GRE header and IP and outer Ethernet header also not there. This is the original packet. It reached to VM4. Now we finished with that case 1. Now coming to case 2. This case 2 is ping between two interfaces which belongs to two different VSIDs. It is expected to not work. Let's start pinging. Now I am start pinging. We can see ping is not working. So the packet VSID is 200 is dropping in Nvgre, means in DPDK. So as expected, case 2 is not working.
Thanks, Bhargav. So we have seen how Nvgre enables creating multiple virtual layer 2 networks using the encapsulation technique and virtual subnet identifier. The few things that are not included in this demo: one is the learning mechanism to derive mapping between provider address and customer address, and another one is the mechanism to transport broadcast and multicast traffic of virtual layer 2 networks. We hope to include these features soon in this demo. That is the end of our demo. Thank you for your attention. Please let us know if you have any questions. Thank you.